using whatever operations to get each of the numbers. So we can use, addition, subtraction, multiplication, division, which I'll probably just write as fractions, like 4/4, which is 4 divided by 4. And we can use like square root or factorial, which we talked about last time. So 4 factorial is 4 times 3 times 2 times 1, which is 24. And stuff like that. We can use exponents, and in this case, we can do like 44. I'll allow it. It's not really an operation, but we're squishing two 4's together, but it counts as two 4's. And we can do like 4.4 or 0.4. I think that will help us a bit too. So I'll allow it, even though a decimal point is not an operation per se, but we're combining the digits like that. And yeah, I mean, we can use other functions like logs and stuff like that, logarithms, but I think we're gonna pass on that for today. I'm not gonna be too creative, I don't think, just because this is a lot of numbers to go through. So if there's a bit of symmetry like last time, I might just take it. And by symmetry, I just mean like if I can add 4 to get one number, but then like subtract 4 to get another number, I'm gonna take it. Just because I want to keep this very relaxed and kind of just move through the numbers. Besides, if you are using this to fall asleep, I feel like it doesn't really matter. It doesn't really matter. I'm just repeating the 4's and the operations for this purpose. It's very tedious and just kind of like, I don't think the point is necessarily to be challenged with this puzzle tonight. At least that's not my goal. So if you want to come up with something a lot more clever, and that's perfectly fine, but this isn't like a competition or anything, so let's just hang out, enjoy, relax, and if you happen to drift off to sleep, that is perfectly fine. So, 26, let's go. So, I have a feeling I'm going to use more factorials in this one than I did for 1 to 25, just because with 1 factorial, I can already get to 24 with these larger numbers. I can then use 3 more 4's to get the remainders. Like, I just need 3 4's to get to 2, which I think I can do. But you know what I mean? It's only investing 1 4 into this to get to 24 already, as opposed to having to do like 4 times 4 to get to 16. I think exponents are too big. Like, I mean, I guess we could do stuff like 4 to the power of root 4, which is 4 squared, which is 16, but you might as well do 4 times 4 in that case, right? So, if we just want 1 4, I think factorial is going to be the way to go here. So we could just do something like 4 plus 4 over 4, right? So this is 24 plus 4 plus 4 is 8 divided by 4, so you still need to do division first, which is implied here, but 8 over 4 is 2, so 24 plus 2 is 26. So that's the idea. Like, this would be one example of a solution. Of course, there are going to be multiple solutions or many solutions, but you could do something like this. So here we get 26, but we use exactly 4 4's. 1, 2, 3, 4, and only 4's. So, like, if I just did 4 factorial plus 4 minus So then 428. Then instead of subtracting 1, I'm just gonna do subtract 0 or add 0, right? Because this is already 28, but I need 0 with 2 more 4's. So just plus 4 minus 4. I know it's not, really creative here, but I think there are plenty of numbers that will come across that will make us have to change it up a bit, so I'm gonna take these while I can. I already forgot my number. 29. Alright. 28. Yeah, that's 28. Okay, so for 29 we have 24. We need to get 5 using 3 4's, which is also fine because it's 4 plus 1. Beautiful. 24, 28, 29. So 4 for 4 is 1. Very good. Okay. So far, so good. 30, 30, 30, 30. So we need exactly 2, because we have 24, 28, 2 with 2 4's. So this is the nice part about 4's. Specifically, is root 4 is 2. So 4 divided by 2 is 2. So that's nice also. 24, 28 plus 2 is 30. Very good. 31. Okay, so oof. So this is 28, but we need 3 using 2 4's. I don't know that we can do that. So not this, because we still need exactly 4 4's. So if we do 4 factorial, we need 7 using 3 4's. Can we do that? So 24 plus 7, so we need to get to 7. How do we do that? Let's see. Can we do it? I don't even know if we can. So like 4 times 4 is 16, which means we would need 15 using 2 4's. So no. I think 4 plus 4. I think, can we do this? Let's see, so if we did 44, I would have to subtract 13, but that's 2 4's. Can't get 13 using 2 4's. Okay, so I think we have to use this factorial here in this case, because everything else takes multiple 4's, which leaves us with not enough to get an odd number. Okay, let's see. What about 44 for 4 is 11, but we can't get to 10 left, or 20. Okay, so 4 factorial is 24. So that's only one more 4, which is nice. Oh, okay, I got it. 4 factorial plus 4 is 28 divided by 4. There we go. Because that's 24, 28, 7. So 24 plus 7 is 31. Not bad, right? Not bad. That one's tricky. I think we're going to really have to rely on the factorials here. 32. So this is 7. I don't think we need it now. So we have 24 plus, okay, so 24 plus 4 is 28 plus 4 is 32, but then we still need a 4th. So plus root 4, or you can just do like plus root 4 times root 4. It just happens to work out to be the same, right? So 24, 28, 30, 32. Nice. Multiples of 4 are quite nice, I think. Okay, this one because I can't think of it. 36, like 4. I think I'm always just one off because to get an odd number you need either like some roundabout multiple like we did. Well, okay, so if we did 7, actually now that I'm thinking about it, we have 7. No, it took us 3 4s to get 7, right? So then we need to get 30 for the rest of it. I'm gonna come back to this one. So for like these odd numbers, I think you need to either do the 44 and have it work out with the remainder, or you need to come up with like a multiple. So like if I, okay, hold on. If I multiply by 2, I have 74. So I could do like root 4 times and then somehow get 74 with the 3 4s. Maybe something like that. So 4 factorial would be 24. I don't know. I think I'm going to come back to this one. But it has to be something like that, especially because 37 is prime, right? So maybe we divide by 2, like 4 factorial plus 4 factorial. I don't know. Let's come back to this one though. I'm going to keep moving. So 38. Hopefully this is nice too. Nicer. Like all the even ones are pretty nice so far. So 2 times 19 or 40, 36 plus 2. So can I get 36 using 3 4s? I don't know, because then I can just add root 4. I can do, oh, we're entering 44 territory, like 44 minus 6, and that's okay. Like this is 40 minus 2 is 38. I think I can do this for like a lot of the 40s. So 39 would be, well, I can't do that here though, right? Because if I have 44, I need 5 with 2 4s. I don't think we can do that. That's awkward. Like, I'm wondering if we need to do logarithms for some of these, but I don't like it because technically, I mean, I guess it's kind of the same for square roots, because when you just write this symbol, technically there's like a 2 there that you're not really counting. But same thing for like logs, like logarithms, you're kind of assuming a base 10, or like natural log is like base e. I guess for some reason I wouldn't allow natural log, but I would allow log in this. I'm wondering if we actually have to use them. But for right now, I'm gonna try not to. 44 minus 5, 36 plus 3, but the 3, like again, because it's odd, I think I'm gonna put this to the side also. When I did this like in middle school for fun, we had this as like a little challenge problem, or like a little, I mean it's not extra credit per se, but you know, it was like a fun puzzle. And we would write all the numbers out, so like 1 through 100, and if you just happen to get one of the numbers, you just fill it in. So we didn't have to go in order like this, which I think is actually kind of more challenging. Because then, like, as soon as you see a pattern, you can just fill it in. So that's why I'm kind of just putting this to the side and just moving on if we have it. So like 44, I'm on a roll with the 44 stuff, so I'm gonna just keep going with it. So I need 4 with 2 4s, which is fine. So, you know, minus root 4, or any variation of this. 44 minus, however you get 4 using, what am I doing? Oh, well, I mean, I guess you could just distribute like this, like factor out the negative 1 or negative. So just root 4 plus root 4, or any way to get 4. Or like even multiplying is fine too, right? Because root 4 times root 4 is 4. 2 times 2 is 4. So that's fine. Either way, it's 4 4s. Or I'm thinking you could do like 4 times 10 even. So these numbers are really nice to work with. 4 plus 4 plus root 4. Root 4. So that's 10. So I'll take it. That's good. That's 8 plus 2 is 10. 4 times 10 is 40. Okay, 41. 41. For some reason this is harder too because 44 minus 3. I feel like this is the same problem that I have for 39. It's like these two mirror each other. Because if I can get this one, I can get this one. Vice versa. Because I can't get 3 using 2 4's. That's my fundamental problem. Okay, so if I got 9, I would have to do 22. But 44, no, it's not the 44. Okay, so 4 factorial is 24, which means I would need 17 using 3 4's. 17. Can I do something like that? Like, for, what did this would be 11, right? Oh, is that this? 11. No, that's for 35. Did I do this for 35? I don't even remember my solution, but this would have worked, right? We can do that cute like 9, but now we're gonna do this for 11. 11 plus 24 is 35. Okay, I'm gonna put 41 also in this little compactlator pile. They're all odd, they're all separated by 2, so I feel like if we can get one, maybe we can get the other 2, I'm not sure. We're gonna come back, I promise. 42 is 40 plus 2. 44 minus 2, that's it. 44 minus 2, so minus 4 plus root 4. And this is why using 4's is so nice, because of the square root and kind of multiplying by itself, and like the square root of 4 is nice, it's 2, but you can also kind of double up on operations if you need more 4's to get exactly 4. So this is 40 plus 2, and we have 1, 2, 3, 4, 4 4's. Good. 43, probably just pretty much going to do the same thing, right? 43 is 44 minus 1, so that's 4 over 4. I'll take it. 44 minus 4 over 4. I'm just thinking of like the one person who like doesn't even like using 44 together in this puzzle, but I'm wondering if there's any other way to do it, unless you get fancy. But that would be really funny if you're like, I don't think 44 is allowed, because then I just did that for like every single one of the 40 so far. But I'm just speaking of, gonna do this for 44. So 44 minus 4 plus 4, or anything that cancels here, so like minus root 4 plus root 4, anything that cancels. I'm gonna take it. So then 45, same deal as for 43, right? Just gonna add 4 over 4 instead of subtract. In fact, for 44, I could have just multiplied as well, just straight off. 44 times 4 over 4. That's funny. For 46, I think I'm going to continue down this 44 train. So 44 plus 2, so plus 4 minus root 4. No problem there. 48 minus 2 is 46. And get 7. We did 7 before. 4 factorial plus 4 over 4. So then we'd have to do something here. No. Okay, let's see. I think we can do this one though because we have 48. We have 4 factorial times root 4 over 48 minus 4 over 4. There we go. Or like just 4 factorial plus 4 factorial. That's 48. It's 24 plus 24 minus 1. Okay. So then for 48 we would just multiply instead of subtract 1, which I'm going to definitely take. Take it when we can, right? So times and times. So that's 48 times 1. I think we could do this just like 4 times 12. So just 4 times 4 plus 4 plus 4. That's fine too, right? 4 times 4 plus 4 plus 4. Or we can just keep going down the 44 path. That's all fine. Yeah, 48 is pretty straightforward. 49. We're almost there. 49 would be what? 48 plus 1. Okay, so just 4 factorial plus 4 factorial is 48 plus 1. So it's the same thing as like the 47 pattern. So subtract 1, multiply 1 to get 48, add 1 to get 49, and add 2 to get 50. So we just do this for 50. 48 plus 2, or 4 factorial times root 4. Seems good enough to me. So, not too shabby for a first pass through, right? We have 37, 39, you found